Welcome to part 1 of the Indigo material editing tutorial. We'll begin with the diffuse or matte material, as the other materials are essentially generalizations of this basic material type. Here we see a simple piggy bank model with a diffuse material applied. Diffuse materials don't change appearance with direction, in other words they scatter light uniformly in all directions. Let's compare this with the Phong material type. The Phong material takes this diffuse base, or substrate as it's called, and adds a glossy coating on top. The influence of this coating is controlled by its IOR, for index of refraction, which is set to 1.5 by default. As we increase the IOR from 2 to 8 to 80, we see that the material takes on a progressively harder and more polished look. Instead of using an unrealistically high IOR value to achieve a metallic effect, we can instead use the specular reflectivity option, which also allows us to set a color. This is useful for colored metallic surfaces, such as Christmas decorations. We also provide a large collection of measured material data. These are called NK materials and are usually used for metals such as aluminium, gold, and copper. As we can see, the reflections are quite sharp and well defined. This behavior is controlled by the Phong material's exponent, which is set to 10,000 by default. Lower exponent values increase the roughness of the material. So for example, with exponent 1000, we see that the reflection has become considerably softer. We now go back to the IOR1 Phong, or equivalently the diffuse material, so that we can compare with the other generalization, RN-Neo. Instead of extending the diffuse material to allow for a shiny appearance, as Phong does, RN-Neo goes in the opposite direction, allowing for rougher materials such as clay, porous concrete, or even the surface of the moon to be accurately modeled. The roughness of the RN-Neo material is controlled by its sigma value, which defaults to 0.3, producing a noticeably flatter appearance than diffuse. With sigma set to 0, it exactly reproduces the diffuse material, and after about 0.5, the darkening due to interreflection becomes dominant. Finally, all these materials share a basic color parameter, which can be defined in a number of ways, the simplest being a constant RGB color. Thanks for watching this video, and please feel free to leave a comment or mail us at support@indigorender.com if you have any questions or queries.